Okay, so very good morning, friends. We are discussing about this chapter number 4 in production and operation management. The chapter is production planning and control. So in the last lecture, we have discussed numericals about the sequencing. First numerical we have discussed about it, n job and 2 machines, and further is n job and 3 machines. Then how to convert these 3 machines into 2 machines, and how to solve the numerical by using this Johnson's approach after conversion that we have discussed. Now today we will be discussing about this scheduling, then what is forward and backward scheduling. Then again some points which we have already discussed, like dispatching, expediting, that are there. Then we will discuss somewhat about inspection, then evaluation, and then then we will go for the last point, that is MRP, material requirement planning, and what are the advantages and scope we will discuss, and we will finish this chapter today. So let us start scheduling. Scheduling can be defined as prescribing when and where each operation necessary to manufacture the product is to be performed. So we have already discussed 2 points are major: when and where. Consider any one operation, when that operation is required to perform and where that operation is required to perform. When it will start, when it will complete, it will have the some essence of this time factor. And where, for example, turning operations, so you will go for ordinary lathe, you will go for a special purpose lathe machine having some you can say attachments, and whether you go for CNC machine, the same operation can be performed on different machines. On which machine the operation will be performed? This is the answer of where. So when and where each operation that is required for manufacturing is to be performed. This answer is in this scheduling. It is also one of the other approach, establishing the times at which to begin and complete each event or operation comprising the procedure. When the operation will start, what is the time it will take, and for this particular time the operation is in progress. Okay, so this is scheduling, establishing the times. Then the principal aim, main aim of the scheduling is to plan the sequence of work so that the production can be systematically arranged toward the end of the completion of all product by due date. Two important things are there. To plan the sequence of work, what is the sequence, how the product will go, one machine, two machine, three machine, four, like this, how it will go, then how at how many stages inspection is there. Okay, and production can be systematically arranged toward the end of the completion, so that whatever the operations are there, that all will completed and the product is finished product, completing all the operations by due date. It is very important. So what is the expected date of completion? That is important, and whether we are achieving that. So due date is also considered in scheduling. So these are different approaches. So main point is when and where that operation is performed, and again when it will start, it will begin, what is the time required for that operation, and when it will end. So these are the points in this scheduling. What are the different inputs for this scheduling? So there are different inputs. One by one we will discuss this performance standards. So the information regarding this performance standards means what? Standard time for operation. If you take a simple turning operation, staging operation, a drilling operation, for drilling 20 mm, that's a diameter hole, for 50 mm length, what is the standardized time is required? Can we directly go for 20 mm drill? Question number one. So, but centering operation will be done then direct 20, or you have to go for 10 and 22 drills depending upon the material. So this is further again bifurcation of that particular time. So the information regarding the performance standard, that what is the time required for a 20 mm drilling a hole of 20 mm for a length of 50 mm, helps to know the capacity in order to assign the required machine hours to the facility. Again, you will go for drilling that operation on lathe machine, you can go for that operation on drilling machine, or you are using any CNC or any special purpose with some jigs and fixtures specially for that drilling machine. So depending upon all these cases, the performance standards will vary. Lathe machine only one job, it may take some time. Drilling machine, for example, lathe machine, it may take 5 minutes. Drilling machine, it may take 4 minutes. And if you go for some additional jigs and fixtures on the drilling machine, in which 6 different jobs can be drilled at a time, so 4 minutes will be taken, but the quantity will be 6 jobs. So it will not take 24. Again, loading and unloading time is different. So this is the standard time of operation, and this will decide to know the capacity, whether we will go for a drilling machine, can we go for only one, or whether we can go for some arrangement of drilling so that 6 drills can be drilled at a time, or we will use jig machine, and just by this jig will guide the tool. You are knowing the jigs and fixtures, so jig will guide the tool, and the same operation can be performed in 2 minutes only. So that 6 drills, let it consider one by one. Within 12 to 13 minutes, that drills will be over. So again, this is another approach. So the standard time of operation is input for scheduling. Units in which loading scheduling is to be expressed. Now we will say, sir, what is unit? So see, generally unit is hours. Depending upon this micro scale, it may be in minutes. If you go for CNC scale, it may be in 2.5, 2.35 second, 2 minutes 35 seconds are required for performing this operation. Okay, this scheduling input can be in terms of shift also. If a company is operating in 2 shifts, and the target may be given that for one machine, any simple lathe you go for, any drilling machine you go for, the target for that one lathe or one drilling machine is that drilling of, for example, 96 items, whatever is they decided. So 8 hours, 96. So you can see divided by 8, 12 hours, 12 items per hour, it will be the rate. Again, you divide that 60 minutes by 12, you will come to know that 5 minutes. But it is a continuous operation. No break is considered here. Continuous, the machine is operating. So this may be unit, may be per shift or per hour, per minute. Some of the operations are there, friends, where the units, you can say one of the operation is started on very bigger machines like horizontal boring, numerical control, HBNC, or some heavy duty jobs are there. So that one job will go for let us say that 15 days on same machine. So in this case, you cannot go for scheduling for minutes. So directly the scheduling in terms of days as far as that particular operation and that particular machine schedule is concerned. So it depends. Effective capacity of the work center. What is the capacity of the work center? What the work center having capacity to finish the job with whatever quality desired. So this is the capacity. CNC machine is having different capacity as compared to other. Very simple. Demand pattern and extent of flexibility to be provided to rush orders. This is another input for scheduling. So demand pattern. Demand pattern. What are the different products required in the market as far as the time is concerned? Or every month that 100 items of one series will be required in the market. Okay, type 2, every month 550 products are required in the market. Type 3, another product, every month 300 products are required in the market. This is the demand pattern. And extent of flexibility provided to rush the orders. This is one part of scheduling. So one job 100 per month, job 2 550 per month, job 3 300 per month. Okay, this is your standardized scheduling. The extent of flexibility, if any emergency order is there, then can we meet? Or if any order is in rush, for example, that 350 products are required at the end of the month, but the market situation is means you can say in such a way that the jobs are required at the mid of the month only. So again, a rush will be there. Which operation is to which should be compromised, and where should we go for unloading that job, and this job the priority is required to be given job number 2. So this is flexibility for rush orders. Overlapping of operations, very important. So two operations may be overlap based on the machine, based on the job, and individual job schedules. Again, this is not only the planning of machine, individual job schedules. So if any job order production is there, then in that job order production, the one job may go for, you can say, 1 year. some larger jobs are there. You can say any big containers or any big tanks. So it is not the case that tanks are required continuous. So let us assume that, or any special purpose order, like any for required for defense application, required for nuclear application, required for aerospace application, or any jigs or fixture, that is also required to be manufactured. So it is also one of the orders. So like these individual job schedules, and this, these all will act as the input for scheduling. By considering this performance standards, the unit in which they express, then capacity of every individual work center, then what is the demand pattern, what is the extent of flexibility that can be go for, some plus, some minus, as per as the rush orders are considered. Then what are the overlapping operations and what are the individual job schedules? So these all will act as the input for scheduling. Let us have a look just for understanding the concept forward scheduling and backward scheduling. So a very simple concept is there. So forward scheduling, obtain the raw material and starting the operation 1, 2, 3, 4, 5, 6, 7, and going for the final assembly. So you can see here, so different operations are there, and final assembly after this time period 9, the job is ready, but the required date is longer. So this is covered earlier, but every time this may not be the case. So forward scheduling, starting the taking the raw material and going for scheduling as per the requirement and meeting the schedule. Backward scheduling, it is in some reverse way. So very first, that end date is taken into consideration when that job is required. For example, let us say that 25th of March. What is today's date? 4th of January. So 25th of March at one side, 4th of January at other side, and what is the time span available in between? In this schedule, the obtaining the raw material, performing the operations, and finally meeting the date. So it is the schedule, backward schedule is by considering the final assembly date as the last date or dispatch date, and then go in the reverse manner. Okay. So everyone is each of these having the pros and cons of this different methods. So this is just concept. Okay, friends. Now production control. We have already discussed about dispatching. And then follow up we have discussed. We will discuss something related to inspection, evaluation, and corrective steps, because this all points when we have discussed this production control, production planning and control in detail, all operations we have discussed in detail. This is just a where we have to start and what is the process and what is our goal. Okay, so production control. So here you can see the production control is the function of management which plans, directs, and controls the material supply, processing activities of an enterprise so that the specified products are developed by specified methods to meet the approved sales and program. Okay, now what is this production control? So production plan is made. So whether that activity is going as per the plan in terms of quality, in terms of quantity, by considering all the aspects, this is nothing but the production control. And then if it is not as per the plan, then taking the appropriate actions so as to bring it on the plan. So this is production control. Okay, dispatching. Dispatching is the routine of setting productive activities in motion through the release of orders and instructions in accordance with the previous planned times. So we have already discussed this. Just for revision I am taking, because I want to discuss more today related to MRP and these limitations of PPC. So these bits we have already discussed. Just for revision purpose I am taking these bits once again. So dispatching, this is the execution phase of planning. Whatever we have planned to start the activity, it is nothing but dispatching. It is not the final dispatch, the dispatch of any material or anything to. This is not that dispatching. So this is to assign the definite work to definite machine, work center, and manpower. To assign the task, to issue the required material from the stores, to issue the jigs, pictures, tooling, and make it available at the correct point. For example, in grinding operation is required that some grinding wheels are required, some cutting wheels are required, buffing wheels, polishing wheels, any single point cutting tools, then separate carbide tools are required, for any drill tools are required. So whatever required, jigs and picture, that issue and make it available. Release the necessary work orders for starting the production. Time ticket when anyone job will start, what is the standard time required for that job, and when the job will end. So this is time ticket. To authorize timely start of the operation, giving order that start the production of this particular activity. To record the start and finish time. This is also important. This will help for control on each machine. So recording the starting time for any one machine for any one job, and recording the for machine also, for main also. If we are not as per the production plan, then this recording time will help you whether there is a problem with respect to man, whether there is a problem with respect to machine, or if not in these two, whether there is a problem with anyone with material, then you can say with the toolings and the different jigs and pictures that are given. This is under dispatching. Then some review about expediting. Expedite, to accelerate, to push. So this is the control tool that keeps the close observation and progress of the work. This is nothing but follow. It is a logical step after dispatching, which is called as follow for progress. I have given you example that today is the 4th. So there is a one target for this month 30, assuming that 31 days are in the January, and assuming that 6 holidays, 5 Sunday plus one set, Republic Day on 26. So 31 minus 6, 25 days will be there. And considering all these things in mind, that 25 days per day, 50 order, and 750 is the target we have to reach. Now, today is the day 4. What is the target should be reached? So considering one holiday, it should be 150 at the end of today. So if it is not getting 50 per day, then what is the problem? Because to analyze the problem after 15 days, if we are lagging every day by 10 units, then what will happen? After 15 days, the lag will be of 150. So if we will come to know on day 1 itself that 50 is required to be achieved, but the target is achieved 40, so that corrective actions from day 1 itself can be taken. This is follow up and expediting and accelerate that. Now, okay, this is the time after analyzing, you will come to know that, okay, maximum 2 can be increased. We will go up to 42. After 42, we cannot go for a single product within a shift, and you are running only one shift. So here the step required is to go for some overtime for that remaining 8 items, every day 2 hours extra working, or to go for some rescheduling so that the 50 items can be produced, to utilize more manpower, machine, check the material is available for that 50. Okay, material is there. If we have planned that 50, we can go for. Then by additional measures, or last option is go for some, what you can say, subcontract, that all the products, if not possible at our end, or some of the operations, if they are required to be performed by other parties, so give it to some subcontractor, and take some operations, get it done from outsourcing. We can say subcontract is outsourced. So these are the various steps. It coordinates extensively to execute the production plan. What is the production plan and how it will be executed? This follow-up, I have given you example. Identification of delays and interruption because of which production schedule may be disrupted. So, okay, I have given with example that if every day 50 is not achieved, this is the identification of delays. To formulate the action plan, this also I have explained. What is the action plan? To go for 2 hours overtime daily, then to, if not, to have some of the workers working on this holidays also, and it is in many of the industries that overtime they will get, and for holiday working, and next subcontracting or increasing the work centers if other jobs are that not that much urgent. So these are the many ways. And to see the production is rate is in line with the schedule. So after you apply these 2-3 different techniques with this band, management had taken the decision that okay, we will go for every day 2 hours for this operation only, then we will be going for 50. So immediately the action started from next day. So now the further task is, okay, action is taken, 2 hours additional work the workers are doing for some of the operations, and remaining they are in line. Now whether at the end of the day after taking the action, whether that 50 is target is meeting, if yes, continue, if not, again go for analyzing the situation and taking the corrective action. This is in that expeditive. Now inspection is a control tool, and it is, again I will say, if you apply it for quality, it is quality control. Though the aspects of quality control are the separate function, this is of very much important to PPC, both for execution of current plan and scope for future work. So this is, though quality control, it is very, very important. Same example I will continue. If you are achieving 40 and after having some additional steps, you are achieving 50 per day. Okay, 50 target achieved. It is not only the case that having the number what is required, we can say target achieved. No. After inspection and this quality check, when you will come to know that though 50 is achieved, whatever after 2 hours, daily 10 hours working, 8 plus 2, we have taken 2 as the corrective measure action. So just we are discussing one example. You will come to know that 5 jobs are defective. Then you will go for analysis, material, no problem. Up to operation number 1, 2, 3, no problem. Operation 4 to operation 7, something goes wrong. Again, you will see in deep, then you will come to know that operation 4 itself, somewhat plus minus, and there the defect or whatever the minus size star. Then where is the problem? The problem maybe with the worker. The problem may be with the workstation, with the machine, with the tooling. For example, if you are drilling, the worker is using any jig. The jig is inspection quality control checked, and the operator job is just to put the job on the jig and just go for drilling and processing next. Now, if the jig is having some error and the error is translating, or I am saying becoming cumulative, that some more error will be there in that drilled hole, again it is neither the fault of machine nor of operator, because it is there due to the jig. Just an example I am giving. So this is also one of the important stage. This forms a basis of knowing the limitation with respect to method. So I am saying that operator is doing his job correctly, machine is also right, but with respect to method, by using this method, this cannot be possible, or processes, which is very much useful for evaluation phase. For example, if you want to go for achieving a 30 micron surface finish, or you can say 30 micron tolerance, and you are using the operation of that universal drilling machine, and if you are checking that inside, it will be more and more rougher. You cannot achieve up to 100 micron also. So here you have to load the job for rimming, and then you have to go for the smooth rimming, and then super finishing operations you have to go for. This is for surface finish. Then this is for the stringent tolerances, depending upon which machine you are choosing. If you are having a very high surface finish requirement, and if you are using, so you have to use this you can say grinding operation, then lapping, honing operations, these are the different operations you can go for. So cylindrical grinding is a separate arrangement for that external, you can say very less material removal rate and very highest surface finish we will get. So these are the some of the operations. So depending upon the requirement, so this will give us what are the limitations of the method. If you are using the method itself or process itself wrong, the final output cannot be good. Or good means as per the expected, it is not good or bad, as per the expectation. So this is about inspection. Then evaluation. This says, though neglected, is the crucial for the improvement of efficiency. A thorough analysis of factors that are having great influence on the production planning and controls, and help to identify the weak spots where the attention is required. And then corrective action will be there, planning will be there, and feedback will be there. So the same example we will continue, only we are discussing with one example, that 50 is the production required. we are getting 40, 2 hours increase. Again, quality we have checked up to mark. So this is the closed loop cycle. And the success of this step depends upon the communication, data, and information gathered. So success of this step depends upon this very important communication. Very first, it should be analyzed that 50 target is not achieved. Second, data and information gathering. At what stage there is a delay, and what are the lacunas, and where the focus is required to be given so that the 50 target per day is achieved. So this is nothing but evaluation phase. Corrective measures, we have already discussed what are the actions taken. Now we will come to this last point of PPC, and then we will go for MRP. So limitations of production planning and control. So this production planning, though we are discussing as a chapter number 4, and we have discussed a lot of things from planning, then scheduling, expediting, follow-up, etc. Who will perform, where will perform, when to perform, how to perform, everything is decided. Okay. So this is a very nice thing that are we have seen the advantages and the scope of this production planning and control. Now, friends, this is coming to the last point. This production planning and control is having also some limitations. So PPC function is based on certain assumptions or forecast of customer demand. So it is having certain assumptions. Forecast of demand, we have discussed in forecasting, the demand may be over forecast or under forecast, but the PPC is based on the forecast. So plant capacity and availability of the material. What is the material available in the market? What is the, we can take the material, what is the capacity of the plant, and it is depending upon the forecast. So depending upon all these factors, the success of the production planning and control depends. Employee may resist change in production level set as per the production plan. Now employee may resist the production level. For example, I have seen, given you idea that 50 is the production rate required. Daily 40 are produced, and that 40 also, if you are saying that this drilling operation is required to be finished within 5 minutes and 1 hour, 12 jobs should be there. Employee may resist. He said that 6 minutes are required for each job. Again, that loading and unloading, if you consider all the time, then also we can produce maximum 9 jobs, not 10 also. And what production plan is suggesting? 12 jobs per hour. So this is the variation, and this employee and this is generally observed in the industry. Whatever the production level set as per the theoretical calculations and the previous experiences and whatever the database available, but there may be resistance from the employee side that okay, no, this is not possible in this time. Your standards itself are wrong. These situations are in the common in the industry. This process is time consuming when we need to carry out routing and scheduling function for large products. So I have given you the small product example, but if you take very large product having 500 parts, and we have to go for assembling that 500 and final one product will be there. So under such condition, this is very time consuming. This function become difficult when environmental factor changes rapidly. Very important. Environmental factors. You are preparing this production planning and control. Everything you are preparing, but for example, this operating in any of this area like Uttarakhand, one of the factories there, and immediately snowfall starts. Or you take the UK and US based countries where there is a heavy snowfall, and again what is target decided that the operator will come immediately, he will start to work, and the 50 is the target. So though he will come, whatever the atmospheric and that other conditions, when he will start the work, and though he will start the work at time, due to this climatic condition, the effect of severe cold, whether his efficiency is that he can produce that 12 jobs per hour, a big question mark. This is just I am giving that example, snowfall. In our India also, you can assume that if the temperature is outside, for example, 45 degrees Celsius, 48 degrees Celsius in Nagpur, and in the countries like Oman, etc., outside Gulf countries, the temperature is 55 degrees Celsius. Then again, it may have some of the effect on that productivity. And again, the target meeting and the production planning control, what we have decided, it is quite difficult to achieve. So this is the environmental effect. This is required to be considered, and this is the limitation. And friends, now let us move to the last topic of this chapter, and very important concept, that is MRP. It is not maximum retail price that we have seen everywhere. What is MRP? 100 rupees, 105 rupees and 10 paisa, etc. on the strip of, you can say, the medical tablet or everywhere, all the products. MRP we have heard, and then we might have heard what is the discount. So it is not totally related. It is very, you can say, a good concept having very great significance as far as the effective implementation of this production planning and control. And apart from this PPC, whatever to achieve the targets and to meet the customer needs and goals, this MRP plays a very vital role, significant role in any of the enterprise. So this is material requirement planning, MRP, material requirement planning. The material requirement planning is a technique for determining the quantity and timing of the acquisition of dependent demand items needed to satisfy master production schedule requirement. This is standard at definition. We will go and we will understand, discuss the simplified way. So MRP is a technique for determining the quantity and timing of the acquisition of dependent demand item. So what quantity is required, at what time it is required. It is everything about the requirement of material. What quantity is required, when it is required to satisfy the master production schedule requirement. Master production schedule, it is the schedule of any company that which product, what quantity, when to dispatch. You can take any of the example that any one company is having 10 different products in one plant. So product number 1, 1000 items or quantity required to be dispatched. Product number 2, 500, like this. So this is the master schedule of that particular company, that these are the different items manufactured in that company, and this is the master schedule for manufacturing that different products. And material requirement planning is a technique which will determine the quantity and timing. What quantity is required at what time is required in order to satisfy the master production schedule. This is MRP. What is the philosophy of MRP? The material should be expedited when their lack would delay the overall production schedule. Material should be expedited to accelerate, to push in some, to pace up in some faster way. So expedited when their lack would be delayed. So for example, what is the production schedule? That 1000 items are required to be dispatched in the month of January. Okay, and now 4th of January is there. And what is the material required for producing that 1000? We are having only quantity of material from which only 300 items can be produced, and we require 1000 to dispatch. So what about remaining 700? Now shop floor is available, machines are available, manpower is there, but availability of material, what quantity and what time. So this is the time within this 300 quantity can be produced up to 10. So that production manager, or you can say the purchase engineer, should identify this, and then he will go for procuring. Again, procurement is the process. Go for quotation calling and comparison, and then which best quality, best quantity, quality with marginal price. Again, these all things will be there, and then he will place order, and the material will be available in the shop floor. So this is philosophy of MRP. Material should be expedited, to brought in very faster way, to speed up when their lack would delay the overall production schedule. The production schedule should not hamper due to non-availability of the material. There are many certain other factors like machine breakdown, the worker absenteeism, or the rejection, etc. But it should not hamper at all due to non-availability of the material, or non-availability, whatever, correct. And it is not only related to, we can say, the material required for we can the actual production. This is the additional thing also. It is not only that is the raw material for production. It also includes that jigs and fixtures, whatever material is required. Then some toolings are required. Some the single point cutting tool, then multi-point cutting tools and carbide tips are required. Some grinding wheels may be there, some cutting wheels may be there, puffing wheels may be there. So what are the different things that are required? All these will under this MRP. Aim of MRP, renewal of products inventory. So inventory, there is one next chapter number 5, we will discuss what is inventory. Inventory is the just availability in stock. So in one word I can say renewal of products inventory. So the products inventory continuously should get renewed. So whatever old material is, means material available is, it will be used continuously, and it should not empty. Next it will be filled with some of the additional material continuous basis, so that the production schedule will not hamper at all due to non-availability of the material. And to meet the customer orders, see, very important, we are having orders in the market, the company is having good repo in the market. So what is next? To meet the demand and to keep the good faith of good customer relationship, whatever the dates committed to the customer, that company should be in a position to dispatch the required quantity with appropriate quality to that company, to that who is the customer. So this is the to meet the customer order, and this is main aim of MRP, because it all depends upon the availability of the required material in required quantity at right time with appropriate quality. If material itself is not available, no one can proceed further. Okay, so main factors of MRP. So you can say the main production plan. What is the production plan for any of the product? What are the different products required? And what are the different materials required as per as the review of the production plan is concerned, when they are required? In your production plan, one of the item or one of some of the forgings are required in the month of March. Okay, you can demand at the end of February also. If you are taking the material in month of January only, then again we will discuss in that MRP, this inventory chapter. So 2 months you are blocking your that money and keeping buying the product and keeping it with you. The same money can be utilized for another purpose, and whenever it is required, at that time only it can be called, or before some days. So this is about main production plan. Product tree. So product tree, you can say, just I will give you some idea. So you can say these are the two parts that are fitted to one of the main part. Okay, see, this is the, you can say, main part shown by right. Okay, and this is the two parts that are fitted. Okay, when it will go to next, again one more and one more part will be fitted. Again, for fitting this part, here are the some other parts that are required to be fitted. Then this part will be ready, and then it will be fitted. So this is nothing but the product tree. So you can say here in simple ways. So this is your number 1, this is your number 2, directly attaching to the main. This is your number 3. So making 3 number ready, these are the some smaller parts that are required first to making that number 3 ready. And when number 3 ready, it will attach to the main part. Okay, this is your number 4. So when your 4 number is ready, and for making the 4 number ready, you have to these 3-4 parts ready. Then your 4 number will be ready and it is attached. This is nothing but the concept of product tree. And what are the different you can say materials are required by considering the product. Product tree decide that at which stage which material is required at what time. Inventory situation folder. So inventory, what is the inventory of raw material in that any one of the industry? What is the in process inventory, that semi finished good, neither raw nor full finish, semi finish, and what is the finished goods are available. So these are the factors considered for material requirement planning. Then performance report. So performance report of any of the workstation related to any of this, we can say typical any of the unit of batch related to any of the product, and it is also related to this manpower. So for example, any one of the product that you are going for, and the performance report, you will come to know that there are different lines, line 1, line 2, line 3, line 4, line 5. The same product is manufactured in different lines. You will come to know that from line number 2 continuously in one shift, 3 4 products are defective. Performance report. So you have to analyze here line 2 separately. It is not the case that line 1, 3, 4, 5. If they are going okay, okay, no problem. Check continuous means record of that inspection of that lines also, until and unless the more insight is required, more attention is required, that to that okay lines, that attention will not be given. So where there is a problem, line number 2. So this is performance report. Again, in that line number 2, whether there is a problem with material, if same material is provided with all the 5 lines, then where there is a problem. Okay. Then planned order schedule. So it is not the case that only we have to decide about what are the current orders. Orders available up to March. Okay, no problem. We are having the enough material in hand to complete the orders up to March. What about April, May, June, July next? So what are the probable orders of that particular month by having some forecasting and by having some previous database, and depending upon that, what is the material required in the month of April, May, June 2022? It is also required to be analyzed. And special situation report, I have just given you idea. Line 5 lines are there, 1 2 3 4 5. And special situation report, all 5 lines, one batch completely, all failures. So each line is manufacturing 50 products per shift, 250 products are there, 240 or 250 all products failure. Then analysis is made, and then it will come to know that whatever the batch of material is there, the problem is there itself, material only. So now this is special situation. You are having, the company is having the material as per the requirement, but 250 items completely fail. This is a special situation. Now we have to meet the requirement of the customer. That company has to go for additional demanding the material, and again processing is required. So this is special situation, that rejection. Just for understanding, I am giving some example. Then what are the advantages of this MRP, that material requirement planning? Ability to price more competitively. For example, let you can say one of the company Bosch. So this they are making the grinder units and etc. So good quality is there. As far as quality is concerned, no problem. But along with quantity, so if they are having this good MRP system, material requirement planning, so very less rejection may be there. Then whatever the production schedule is there, it is followed. It will ensure the effective utilization of all the resources, and then the boss can compete with the market. So ability to price more competitively, this is the one of the advantage of MRP. If any one of the company 1000 products, this is the demand from X firm, and there are A, B, C, 3 companies they want to quote. Okay, A will say I will give this 1000 products at 100 per piece. B will say I will give 95 per piece. So see, if the company is, C will say 105 per piece. So who is quoting less? Rupees 95. Definitely, if he is in a position to give the quality as per the demanded, the order will be given to him. So why he is able to quote at 95? Effective this implementation of this material requirement planning. Because why the orders are 100 or 110? Because there may be the cases of non-availability of the material, non-availability of the tooling, and more rejection is there. So these all factors, they are not in a position to compete effectively. So for competition, the price should be minimum, and having the price should be minimum, this MRP should be a good, so that then only this lesser price and with more competitors. So one company can compete with more competitors by giving lesser price. Reduce the inventory. Next advantage. So inventory is minimum. Here proper planning of the material. In the month of March, these many forging are required. So the forging will be made available in the last week of February, not from now. Reduce the pricing. Again, this proper planning of inventory, effective utilization of material, less rejection, when and where required and what quantity required, that only material is provided. So this will ultimately reduce the overall price of the any component. Better customer service. If the customer is demanding that 1000 products are required at this material, And if we are having the good MRP, we will meet to the customer as per the spare parts, as per the demand, and good service is there. Better response to market demand, not required to explain. We have discussed this with 50 products and 1000 products. So if we are having good MRP system in any of the firm, then whatever the fluctuation in the market demand, it can also be cope up or tackled. Ability to change the master schedule, very different point. Now you will say, sir, it is master schedule MRP is one of the important part, and now ability to change the master schedule. See, as per the master schedule, if there are 5 products, 1 2 3 4 5, and the quantity required for 5 products is 100 per month, or you can say 100 per day. So let us take simple example, 100 per day. If the firm is having ample resources of this material is available, the company is operating in 2 shifts, the material is available, and let us see that the product number C, they are required 150 per day. If availability of material, availability of tooling, and whatever other things are required, the company can take decision, because manpower is maybe available, then machines are the fixed asset of the company. So if the material is available as per the requirement, they can go for 100 to 150. They can go for changing the master schedule also. Reduce the idle time. Idle time due to non-availability of material. If the required quantity of material is made available in the when as and when required, then less idle time will be there. So this is, friends, about MRP. So these are the different bits that we have discussed. So let us, I will take you a brief review. So we have discussed, friends, the chapter number 4, that is production planning and control. In this, we have discussed what are the different objectives, functions of this production. Then what is the importance of this, how this production planning and control coordinator with other department like routing, scheduling, loading, sequencing, balancing. What is production control? We have discussed dispatching, follow-up, evaluation. Then after having these bits, we have discussed difference between production planning and production control. Then we have seen what is line balancing, what are the different examples, what by taking example we have seen what are the advantages of line balancing. Then we have seen in detail this planning, routing, scheduling, loading, and estimating. In detail we have discussed. Then what is outline for production control. Then what is loading, sequencing, and scheduling. This also we have discussed. We have discussed about then the Gantt chart, the visual load profiles, and then we have arrived, friend, at priority sequencing. What is the criteria for sequencing? What are the sequencing rules? And we have solved sequencing problems. N job 2 machines and N job 3 machines by using Johnson's algorithm. We have discussed the procedure. Then we have solved the first problem, a simple case. Then second problem, we have gone for N job 2 machines with some of the complications that having the same, we can say, jobs for 2 machines, then how to choose the criteria. And then we have calculated the total elapsed time and the idle time. Then we have discussed N job and 3 machines. So here we have discussed that how to convert, what are the conditions for converting. If they are satisfying the conditions, how to convert the 3 jobs into 2 jobs, and then find the sequence. And after sequencing, again our previous method, go for calculating the idle time for 2 machines, that machine 2, machine 3, and what is the minimum elapsed time required, minimum processing time required. Then today we have discussed about scheduling, then some review about the functions like dispatching, follow-up, inspection, and evaluation. Then we have discussed about limitations of PPC, and at last we have discussed about this material requirement planning. What are the factors? What are the advantages? This is the conclusion of, friends, chapter number 4, and in the next lecture we will start chapter number 5. Thank you very much. Just to wait.